Hey guys, Mr. Ray's here to help you out with not just 6.4, but 6.5. These two sections go together like pretty much hand in hand, and there's really no differentiating between the two. They're very similar in how we solve them. 6.4 is a little easier than 6.5. Okay, so let's get this started. When we're solving a logarithmic equation, typically what we want to do is see if we can solve by using the loop and swoop method. So once we have our logarithm isolated, like in this problem here, oh, I guess maybe I probably was short here. I got distracted by that phone call. We have these two sections. So today what we're going to do is go over section 6.4 and 6.5 in your notes. And then for your homework, you have this worksheet, which is fairly long to do. So this worksheet that you guys will be doing is worth double the points. If you need to use a separate sheet of paper to show your work, go ahead and do that. But you'll need to use the concepts that we go over in here to solve these problems. Okay, so let's go back to 6.4 and go through these notes. So when it comes to solving a logarithm, it's like solving a radical or anything else. We need to isolate the logarithm and then eliminate it. To eliminate the radical or log, the easiest way to do that is to loop and swoop. So we're going to loop and swoop here. And in this case, we would get 36 to the 3/2 power equals x. So we just need to take out a calculator, figure out what 36 to the 3/2 power is, or take the square root of 36 and then cube it. But calculator is pretty much our friend here. Oh, quit out of there. All right, 36 to the, oh, it wasn't even the 2 of the button. 3/2 power, we get 216. All right, so that one was a piece of cake. Go ahead, pause the video, try to do B, see if you can do that on your own. All right, let's check it out. You loop and swoop here. So this would be 9 to the 3/2 power equals x. Once we eliminate the log, and then we got to plug that into the calculator. All right, what's 9 to the 3/2 power? The square root of 9 is 3. 3 cubed is 27. Okay, now what happens when we have numbers more than just the log? Like we have 3 times log base 2 of x equals 24. Well, what we got to do here is imagine like there's a parentheses. We need to isolate that log. So we're going to divide by 3 first. So we can get log base 2, not 3. Geez. Log base 2 of x equals, all right, 3 or 24 divided by 3 is 8. Okay, then what we got it isolated, we're going to loop and swoop to eliminate the log. So 2 to the 8th power equals x. So calculator time, this is going to be a fairly large number. What is 2 to the 8th power? 256. And there we go. So why don't you guys go ahead, pause the video now, and see if you can do problem D on your own. All right, problem D is a little bit different here because we have this -4 here. And just like if this was 7x minus 4, we would add 4 over first. So we get 7 log base 5 of x is equal to 21. Then we would divide by 7 to get the log by itself. So log base 5 of x is equal to 3. Once we got that, we loop and swoop to get rid of the log. So 5 to the 3rd power equals x. So in the calculator, 5 to the 3rd power is 125. Okay, hopefully not too bad here. We'll get the hang of this. Keep this going, add some more difficulty to this. All right, what about if we have something more complicated than just log base 5 of x? So we still need to isolate, so we'll divide by 9 here. And so we got log base 3 of negative 5x minus 3 equals 4. Okay, well, we got our log isolated. Next thing we do is we loop and swoop it. All right, so we would get 3 to the 4th power equals negative 5x minus 3. Even if that was just an x or something, we just put down what the expression is. All right, so let's figure out what's 3 to the 4th power. That's 81 if we use a calculator. All right, we are going to add 3 over to 81. So we get 84 equals negative 5x. We divide, it doesn't come out nice, so we'll leave this as negative 84 over 5. Okay, pause the video, see if you guys can do F on your own. If you can, if you get it right, I think you're off to a great start. All right, let's check this out. So we're going to subtract 6 from both sides first. So we get 9 times the log base 6 of 2x plus 1 is equal to, if we subtract 6, that becomes 27. Next, we divide by 3. So we get log base 6 of 2x plus 1, or divide by 3, divide by 9, which is 3. Then we got a loop and swoop. So we get 6 to the third power equals 2x plus 1. All right, calculator time, 6 to the third power is 216. So we are going to subtract 1 over, so we get 215 equals 2x. And then we divide by 2. It doesn't come out nice, so we can make it a fraction, 215 over 2. You guys got it right? Feel good for yourself. All right, the next part of 6.4, what happens when we have multiple logs? When we have multiple logs, we got to watch out for some things. But the easiest thing to do is if we have a single log on one side and a single log on the other side, and they're the exact same log, both log base 6s here in this case, they cancel each other out. Almost like when we had common bases. If I had 2 to the 3x power is equal to 2 to the 5th power, they just cancel each other out. So this becomes an x minus 6 equals negative 8. All we got to do is add 6 over here. X would equal negative 2. So let's double check our work here. These are both the same common log, and we have 1 on each side, so they cancel each other out. So we get x squared minus 4 is equal to 5. We can add 4 over, so x squared would equal 9. And in this case, to take the square root of 9, remember, anytime we take the square root, we got to do a plus or minus sign. And so this problem here, we actually get 2 answers, x equals plus or minus 3. All right, why don't you guys pause the video, see if you guys can do the next problem on your own. Go through. All right, logs are the same. We got 1 on each side, so they cancel each other out. And we got, okay, x squared minus 15 is equal to 2x. All right, it's been a while, but these problems can pop back up. This is a quadratic problem, and to solve it, we need to minus the 2x over. We'll get x squared minus 2x minus 15 equals 0. So we need to go through and factor this. What two numbers multiply together to give us 15, negative 15, add together to get negative 2. That'd be x minus 5 and x plus 3. And so when we solve both of those here, we get x equals positive 5 for an answer and x equals negative 3 for the other answer. Okay. Let's see how we're doing here. So this wraps up 6.4. So 6.4 isn't too bad, but really what we want to know is like 6.5 to help us along with problems, because these are fairly easy and they're almost like perfect case scenario problems. All right, in 6.5, what we're going to do is look at the properties of logarithms and how we can use them to solve. So a couple things about logarithms is if we're multiplying the two logs inside together, that's the same thing as adding two separate logs with the same base. So log base 2 of 5 times 6 is the same thing as log base 2 times 5 plus log base 2 times 6. Division goes to subtraction. So if we got log base 2 of 5 divided by 6, that's the same as log base 2 of 5 minus log base 2 of 6. And powers would actually represent multiplication. So log base 2 of 6 to the 5th power ends up being 5 log base 2 of 6. Now we can actually use that to not only construct but destruct. So let's go through this problem B here to see if we can destruct this. So if I got log base 2 of 3x times 6y times 7d, we can actually change this. Well, it's no log, so it's a common log. If you guys didn't know, the common log is actually log base 10. So we got log of 3x plus log of 6y plus log of 7z. We can break it down like that. In fact, we could break this down even more, because if we think about 3x is 3 times x. So this is log base 3 plus log base x and log base plus log 6 plus log y plus log 7 plus log z. Now, one thing about logs is even though like we have log 7, log 6, and log 3, they don't go together. All the logs have to be, we cannot add logs, we can just multiply them together. So it does kind of change some things around here. All right, now let's think about this. If we want to construct these, so this is already destructed. If we want to construct them, we're going to squeeze them together. And this is really what we're going to use to help solve some things. if I took this log here, we got log x plus log 2y plus log 3z. We work backwards here. If we have addition, that means we're going to multiply them all together. So this would be log of x times 2y times 3z. Or aka, this is really log of, well, let's see, 2 times 3, we got 6, x, y, z. So when we have addition, we can combine them together to form one single log. And that's what we're going to do to solve. So we can only cancel out logs, even though we have common logs on both sides. We can only cancel out a log if we have one log on each side. Now, since these two logs here are the same log and they're being added together, we could change this to log base 3 of, well, 6 times x, so 6x equals log base 3 of 12. So these two logs we can combine together by multiplying their bases, or not their bases, their numbers outside. Now that we have common logs, they cancel out, and we just got to solve what 6x equals 12 is. So all we got to do is divide, and so x would have to be 2. All right, so why don't you guys pause the video to see if you guys can do problem B here. All right, so we got common logs. We have to multiply them together. So we get log base 4 of 8a equals log base 4 of 24. The common logs cancel each other out, or the similar logs cancel each other out, and we get 8a equals 24. All we need to do is divide, and hopefully you got a equals 3. All right, so let's use that to help us with this subtraction part too. All right, subtraction would be division. So we can combine these logs together here, not that one, but these two together, but we're going to divide. So this is going to be log base 4 of 3 divided by x is equal to 27, or log base, you know what? I'm so used to thinking what's ahead, it's not equals regular 27, it's log base 4 of 27. All right, now the logs are going to cancel each other out, so we got to figure out, okay, what 3 divided by x is equal to 27. Well, we have a fraction here. If you forgot from Algebra 1, fractions you can solve by cross multiplying. And so x times 27 is 27x. 3 times 1 is 3. So all we need to do is divide 3 by 27, and that actually simplifies down to 1/9. There we go. So why don't you guys pause, try to do problem B on your own, see if you get it right. All right, so we got to combine those logs to one single log base 4, and it would be 2x divided by 4, and that's going to equal 5. Or, oh, again, log base 4 of 5. All right, the logs cancel out, and we just got to solve the problem. 2x over 4 is equal to 5. I'm going to make that 5 over 1 so we can cross multiply. 2 times x, or 2x times 1 is 2x. 4 times 5 is 20. All we need to do is divide, and so x would equal 10. Hopefully you got that right. Okay, last thing that we're going to do here. Really complicated logs. Okay, so let's break this down into a couple steps. First, multiplicating. We haven't seen this here, but any multiplying on the outside turns it into the exponent. So we got log base 6 of 0.1 plus log base 6 of x squared. All right, we don't have any multiplying outside of here. 6 of 2 plus log base 6 of 5. All right, so we got all these logs here. Next, let's combine these together. We can multiply the 0.1 times the x, and we get log base 6 of 0.1 x squared is equal to, okay, we can combine those together, 2 times 5. We actually can multiply it. 2 times 5 is 10. So the logs cancel out, and we just have a new problem here of 0.1 x squared equals 10. All right, if I divide by 0.1, 10 divided by 0.1 is 100. And we just need to take the square root. Remember, anytime we take the square root, it's a plus or minus sign. The square root of 100 is plus or minus 10. There's your answer. Okay. All right, next. Last thing we want to do is see if we can expand these completely, but mostly solving is what we're going to be doing on your worksheet. So if you want to just stop and start working on your worksheet, that'd be good. The last couple of questions are great ones to make sure we understand all of the rules here. All right, what if we have really generic thing, log of 37xy squared z. Okay, let's break this down. First, we have log of 37 is our first multiplying, plus, all right, we got log of x, and then moving on to the y. Well, we have y squared, so we're going to put 2 log of y. That's how we write the y squared. And then log of z. Always think these kind of spell funny words. All right, pause the video, see if you can do the next one on your own. All right, it should be log 3 plus, okay, x squared becomes 2 log x, plus y is just log y, plus z to the fourth would be 4 log z, and then plus q to the 1/2 power would be 1/2 log q. All right, really long expressions, but they're kind of good practice to go through. All right, now let's see if we can combine these super long things. Okay, all right, anything that's being added, we're going to multiply, and anything that's being subtracted will be divided, and so we'll put those on the denominator. So this is all going to be log of, all right, we got x, we got y, but then we got -2, so we're going to divide by 2, and then plus a, so that means we're going to times by a on the top. It's positive, so we put it on the top. And then over here, -3 log b, so that'd be a b cubed on the bottom. It's cubed because of the 3 on the outside, and then it's on the bottom because of the minus. There we go. All right, let's figure this last one out. Okay, so multiply, multiply, this is divide, and that's multiplied. So we are going to have another fraction here. All right, we would have a 3x on the top. Now this one would be a y to the fourth. It's 3x because the 3 is inside the log, and this one's y to the fourth because the 4 is outside. All right, 6 log z would be z to the 6th on the bottom because the minus sign. And then 8 log a would be a to the 8th power on top. There we go. All right, guys, so take a look at the homework. I'm expecting you guys to spend a full day on this, probably 40 minutes to do this problem. Some of these problems start out easy where you're just isolating the log and looping and swooping. Then once you start getting into multiple logs, okay, you see if their common bases can cancel each other out, solve that problem. And then when you have multiple logs on the same side, you need to compress them to get to one log so you can cancel it out. Sometimes you compress it and then you got to loop and swoop. Like, so in these cases, you'll compress and then loop and swoop. And these problems, you'll compress and cancel out. All right, good luck with everything here, guys. If you have any questions, make sure you guys ask, but we're spending 2 days on this assignment, and this is a pretty big worksheet. So if you have questions, ask. If not, I will see you guys next time. Have a good one.